All right, Emil?
Yeah,
you ready to go?
I'm ready. I think so, at least. So, as Johan said, we wanted to share with you some of the recent threats within iOS and Android as well, because that's one important part of enterprise security in particular. You probably, at least some of you probably seen me before talking about mobile platforms. I'm not actively working within mobile platforms today, just so you know. We have other people in our team focusing only on mobile security, but still, I brought some of the stuff with me today that they are working on, and I hope you find it interesting. It's some of the recent threats occurring, and I have a demo on one of the recent hacks on Android from this year. So what's really happening within mobile security? There are some big trends. One is sending malicious software to your mobile devices through malicious software on PC or Mac, because that's really a great trampoline into the mobile environment, since many of you hook up your mobile phones to the PC or Mac just for charging or maybe for syncing your content. And another interesting thing, which we're going to look at in the demo in a short while, is that there are some accessibility features built into the Android environment that can be exploited for other purposes as well. And that's quite scary, in my opinion. And it's, I think it's a bit unfortunate, because this functionality is very important to have as part of the framework, as part of the ecosystem. So it's very unfortunate that this has now become a target for malware authors. Hopefully that's going to be fixed quite soon. But as you all know, there is a time window before all these patches reaches the actual devices. We also have a couple of overlay attacks ongoing, and that's also powerful, especially when it's combined with these exploits on the accessibility features. That's also included in the demo soon. And finally, there are some new attack patterns. Maybe you've seen, if you live or watch the news in Sweden, then you've probably seen my colleague Marcus Murray talking about the new attacks occurring called Blueborn on the Bluetooth implementation in mobile devices. And application developers is also becoming a target. Maybe you heard about Xcode Ghost, where the development, that's just one example of where the development machines get infected. And by having the development environment infected, you can get code into the software development lifecycle and eventually get signed by the application authors, and hence making your malicious software become part of their application online. But Bluetooth and Wi-Fi, I think that's just begun. There has been some new attacks revealed during this year, and I think that's going to continue, unfortunately. What's especially interesting with the Bluetooth and Wi-Fi attacks is that it's not tied to Android only or iOS only. These have been occurring on both types. And that's partly because of the standards in terms of these wireless protocols, but it also, with some wireless hardware, the wireless hardware manufacturers ship some pieces of code, drivers, etc., or firmware code that's becoming a part of the system software in the mobile devices. So that's also an ongoing trend where attacks target stuff that's going to be in both Android and iPhone devices, for instance. So, but we don't have too much time to talk about that, because we're soon going to dive into Amazon Web Services. But I already mentioned Xcode. Oops. There's something wrong with my clicker here. Let me see if we can get hold of that again. I already mentioned Xcode Ghost, where developers get infected, and that in turn leads to malicious software getting uploaded to the app stores without developers necessarily knowing. This was especially targeting developers in China, the first wave of Xcode Ghost. But there are examples of where this has reached other parts of the world as well. So I think that's an interesting type of attack, even though Xcode Ghost has not been on the radar recently in terms of mobile threats. I still think it's worth knowing about. A more recent example is what's called Deceiver, where malware authors had been able to bypass the review process in Apple App Store and getting their malicious software uploaded to App Store and accepted. And sooner or later, Apple would notice, but some of the applications been there for many months before being noticed, and they've even provided 4 to 5 additional updates to the same application, still without being noticed. And that also shows that the app review process is not bulletproof, of course. What's happening with Deceiver is that even though the applications are getting removed from the App Store, they're still signed by Apple. So it's still possible for attackers to perform what's called a fair play man-in-the-middle attack. Fair play is the DRM protection for Apple applications. So they can still get what's called authorization codes while the application is still on the App Store. And if they have authorization codes for installing that on additional devices, they can still, through malicious software on a PC or a Mac, they can still provision that application over to a mobile device. So that application does no longer have to be still in the App Store. So even if Apple has removed that because they realize that it's malicious, it can still be provisioned to additional devices. So this shows a type of lateral movement in terms of threats moving through the desktop and laptop computers into the mobile devices. I don't think we have too much time to talk about Android examples. We're going to look at the accessibility features instead. This is just so that you know there's an industry behind this. Examples of forced ad clicking through malicious applications or adware, generating roughly around $300,000 per month. And that remained undetected for roughly a year. But we're going to look at Cloak and Dagger. And how many of you have heard about Cloak and Dagger before? Not that many. Great. So then this is something new. That's great. So this is a click, drag, and overlay attack. You draw stuff on top of the regular UI. And by doing that, you trigger the user to push buttons that the user doesn't realize is that particular system setting, for instance. You can use that kind of pattern to make the user install any type of application that you uploaded. They can set whatever system setting you prefer because you control what's displayed on screen. And this affects Android up to 7.1.2. Just as an example, you see the UI box to the right. Are you sure you want to perform this dangerous operation? Well, there is no dialogue like that in Android, but that's just to serve as an example. and you have an OK button, and you have a cancel button. Most users would probably stop and maybe not directly push OK, because it says dangerous at least. So as long as you flag something to the user, it's like a warning, and hopefully they'll ask somebody who knows what's the effect of actually triggering this option. But what if an attacker would display something over that, saying, well, this is no problem, just press OK, but leave the OK space transparent so that the user pushes through the malicious UI onto the OK button below. So you're going to see how this works in practice, and we're going to see how we can activate accessibility features implemented as part of an Android application to retrieve window content, and that's system-wide. So we can retrieve everything that's displayed on screen. And we can, what's called, observe your actions. That means observing and hooking into what's being pushed and what's being not pushed on the screen. So we'll take a look at that before we go on to AWS. Let's see if we can get my phone going here. There is a slight trouble with the focus. I hope you are okay with that. If you have an Android device, you can go home and take a look or pull it up from your pocket. There is a settings menu called Accessibility, where you can activate stuff like TalkBack, where it will read, with voice, read for you what's being displayed on the screen. But as with everything in Android, you can have your own implementation for all this, like accessibility features. And we have an application, a proof of concept application for all this that you can activate. And if you press on, that's really hard to see, right? Sorry about that. I have to read that from the screen, it seems like. It says, do you really want to use CND, CJ, POC needs to observe your actions, receive notifications when you're interacting with an app, and retrieve window content, inspect the content of a window what you're interacting with. So if I press OK on that, you'll see the setting is now activated. So that's an example of a warning, like, do you really want to do this? You have to press OK. You can still press cancel if you want to escape from all this. And hopefully, the user won't do that. Especially, this requires some manual work, right? The user would have to go into menus, the settings menus, and find that accessibility features. And most of the users won't even know that there is an accessibility menu unless they actually require that type of features. But the way the attack works, so maybe we should just go back and see if we can remove that again. So we deactivate that agent and we go into the app instead. And I will just press start, click Jack and attack. This would probably, in a real case, this would probably be like a game, or as everyone's talking about, wallpaper applications. I don't know what people use wallpaper applications for, but still, basically all the malware attacks happen through the wallpaper app. So it's obviously a big interest in that. So this is just implemented as a tutorial. Start the tutorial and press next. So what's actually happening now is, and what the user will notice, is that we're actually in the settings menu. And what we see on screen now is the OK button of that warning dialog. Do you really want to activate this to observe your actions and retrieve window content? But as you can see, something completely different is displayed on screen, and we only have the OK button to press. So we'll press the OK button, and let's see if we have the demo gods with us. See if we can type somewhere. This is Messenger. That's a bad example. Let's use the Gmail application, and we'll set up a new email account. xy.local and password A, B, C, D, E, F. That's what I always use as password for my email. It's a lot easier to remember then. So now comes the interesting part. If we look at what's happened on my screen, this automatically erases inputs after a while. But as you can see, these are the keystrokes for the password input, A, B, C, D, E, F. And with the timestamps, with the information about the device, of course, the application can collect a lot more information from this device about the user's details and everything. We can also see what context this is being inputted in, so that we understand, well, this is probably an email account. And we don't see it right now, but we should have seen the email address input as well, x@y.local as well. But that was removed for some reason, I don't know. The demo gods, I guess. But so hopefully you get the picture. This is not only limited to the built-in keyboard. You have to tailor this overlay attack so that it suits keyboards or pin input, etc. But this is an important threat to understand against Android devices. And this is a new type of threat, a suite of threats. So we might see more Cloak and Dagger related in the future. And I mentioned earlier that this can also be exploited to install additional applications. You know that if you're using Android, you know that when you're installing, you'll see warnings about what types of permissions this application requires. That can be bypassed the same way without the user knowing. So I don't have time to show it right now. If you're interested, come and grab me after the session about AWS, because we have to start on that right now. But I have one additional thing built into all this, and that is that the proof of concept application has been recording everything that I've been saying now and streaming that up to the server in the meantime, without, again, any notification to the user. So that's another example of how Cloak and Dagger is exploited. But now it's time to move on to AWS. I hope you found this interesting. Want to talk more about mobile security? Let me know. I can direct you to other colleagues who know a lot more about the up-to-date information on all this. I try to keep up with everything, but I'm not the best expert on this anymore. All right.
All right. Thank you, Emil. I'm just getting rid of my wallpaper application. And before, while you switch to secure application infrastructure on AWS, yeah, that was a quick switch. I just want to take a few seconds to remind you about Swedish Fika here. We love to buy you a cup of coffee and talk about whatever you see here during these 2 days. All right, Emil, are you ready to go? You need a few more seconds?
I realized that my session timed out, so I need a few more seconds.
Okay.
Keep talking.
Then I also want to take another seconds of your time to remind you about the evaluations. After the last session today, you can win a security lab with one of the speakers here on stage during these 2 days. So take your time, please take your time to fill out the evaluations for each session. You'll find them on your mobile application. All right, Emil.
Yeah, let's get going.
Let's get going.
How many of you are using Amazon Web Services? A couple of. Are you a developer? Yeah. So, and that's becoming common, right? That the developers, they control the infrastructure themselves. Operations are no longer involved, or operations staff have transformed into DevOps staffs, maybe. It depends a little bit on how big the organization is and what type of organization it is. It's still, we have customers who have dedicated operations teams for AWS and Azure, for instance. Just curious, how many of you are using Azure for similar purposes? A lot more. So then you know many of these concepts, but maybe haven't seen it in practice in Amazon. So I hope you find that interesting. And I think it's interesting to look at the legacy model of typical enterprise infrastructure. Even if we're already moving away from this, I'm sure you're familiar with the situation, and this is still the case in many environments. We have a huge number of systems. We have complex integrations between those systems. We have what we more or less refer to as an inside and versus an outside of this environment. And we treat the inside differently compared to the outside. The security situation in this type of environment is extremely complex, of course, to overview. I think, of course, this is to simplify things a little bit, but I think it's time to break this into pieces and make the infrastructure, especially in terms of application infrastructure, more distributed and silos for each application or function rather than having it bundled all together. So this is already happening again. And what we see is that the future is application-centric. We have, in many environments, we have the infrastructure already distributed across multiple clouds. Some clouds on Swedish grounds, some clouds in Europe, some in the US, whatever. And that depends. Sometimes it's sourcing vendors even operating their own infrastructure or controlling their cloud for the application that you bought from them. But I think it's really time to break this monolithic infrastructure so that it's a lot easier to design and overview the actual situation and making one security boundary around each of the silos rather than having one single security boundary around everything. But I guess you heard that many times before. We're going to talk about application infrastructure. We're going to talk about available application infrastructure and secure application infrastructure. And these are very tightly related, of course. available versus secure, or available together with secure, rather. That brings the ability to protect, detect, and quickly recover once you're in a breach situation. Because, as Marcus talked about yesterday, we have to assume breach. Breach will happen eventually. So we need to build our environment in a way so that we are able to quickly recover from a disaster. In Amazon Web Services, there is a concept called the shared responsibility model. And that's just to clarify things about security, that if you run stuff in the Amazon cloud, that doesn't necessarily mean that the security is totally up to them. Or we rely entirely on the security and compliance and the encryption and the secure transfer and everything that's implemented by them. They take care of the security of the cloud. You have to work on the security in the cloud, which is at least as big. Depending on what implementation it is, of course. So you see at the top, customer data. It's not something that they will automatically solve for you. Even if you press a checkbox, encrypted, yes, no, if you're setting up database as a service, for instance. That's not, there is no silver bullets like that. This is important. There is a lot more to read on the Amazon website about this, how they see security in the cloud versus security off the cloud. But it's important to keep in the back of your head when you're designing secure application infrastructure. So let's take a look at some of the AWS pieces or the AWS services. We have many different abstraction levels in AWS. The same goes with Azure and Google Cloud. But we have EC2, for instance, Elastic Compute Cloud, which is really about virtual machines, where you can configure your own environment exactly the way you want it. You have instance types that are optimized for a specific purpose, for memory-intense applications, for instance. You can configure how much memory you'd like, how many cores you'd like, if you want dedicated machines, or you're fine with sharing hardware with others, etc. So this is very flexible, yet it's still very complex to control in larger environments. If you go one step up, it's the ECS, the Amazon Container Service, where you can run Docker containers, and you don't have to worry about the virtual machines and controlling the virtual machines itself. You can continue up the ladder, and Elastic Beanstalk is a service where you just deploy a Java application. And nowadays, we talk a lot about serverless. That's something that exists in Azure as well, by the way. So you've probably seen that. In Amazon, it's called AWS Lambda. And by serverless, if you're not familiar with that since before, serverless basically means that we implement a function taking some kind of input and getting some kind of output from that function. When we deploy a serverless application, we don't worry about what hardware that's running on at the time. But that also means, from a cost perspective, we don't have to pay for service just running overnight, even if there are actually no users using that web service, for instance. So that's a very good model if you have, especially if you have services that are not frequently used. The best way to go is serverless. But always at a price. The the price for this is flexibility. So serverless is not as flexible as EC2, but it's a lot easier to control your environment. So that depends, and of course it depends a lot whether you're running legacy servers or if you're building applications from scratch. If you're building distributed systems nowadays, then you use readily built building blocks like serverless Amazon Lambda, for instance. You might use SQS, which is on the right side, for which is a ready implementation of a queue system. So you don't develop and configure queue systems from scratch. You use building blocks that are already in the services suite. So these are just some examples. Whoops, that's my remote again. It's just to keep you awake. So diving a bit deeper into what available means and how we achieve availability with AWS, because that's also, to some extent, security, right? So in AWS, there are concepts called regions and availability zones. And that tells you where the servers are located. A region is a collection of data centers that are on a specific geographical location. So a typical example of a region is EU Frankfurt, for instance. And within a region, you have different availability zones. These are data centers that are geographically separated so that if Kim Jong-un, God help, drops a bomb in one of the data centers, then that's a bad example. I shouldn't have said that because that would probably affect the other data centers in that region. But you see my point, right? So the point I'm trying to make, like if there is like power outage, that's a better example. Of course, they have backup power. So, but still, if something goes completely wrong within one region, in one data center, that shouldn't affect the other availability zone. So, and actually that's been proven in many cases before, because there are situations where one availability zone is affected somehow, usually by physical circumstances or some kind of engineering mistakes that's been made. And that shouldn't affect the availability of another availability zone. So what's interesting, I guess, for you people here today is that there is a new region coming up in Stockholm next year. You probably read about this in the news. The last thing I heard is that it's still the first half of 2018. Let's see about that. Nothing that's confirmed, so don't quote me on that. Related to availability is also load balancers concept. And this is a great feature to use. I think that if you don't have very specific requirements, there is really no need for you to set up your own load balancer, configure your own load balancer, and worry about that, and having a dedicated big IP expert for that purpose only, or what environment you have. But it's a lot better to use these building blocks if you're moving to the cloud than try to use the built-in functionality as much as possible. There are 3 types of elastic load balancers, and it's called application load balancers, network load balancers, and classic load balancer. Classic should actually be called legacy load balancer, in my opinion, because that's the first type. It used to be only one type of elastic load balancer, just so you understand that. But it's called elastic since it can span over multiple availability zones. So everything is basically built in one region. So that's also one thing to remember, that you usually don't build stuff in multiple regions. If you do, you have to take specific considerations for the transfer or the integration between the regions. If you stick within the same region, things are a lot easier. So the framework is basically built upon this expectation that you build most of your stuff in the same region. And again, elastic load balancer is, the name comes from that it has the ability to span across multiple availability zones, which means that it's transparent for you if one availability zone goes down, as long as you have instances, meaning virtual machines or what containers or what type of implementation you have, as long as you have nodes in multiple availability zones, and those nodes are associated with the same load balancer, you'll still have availability even if one data center goes down. That's interesting. And I would say that application load balancers are the most common to use. That's for most HTTPS, HTTP-based applications, like web services and web applications, where you can have path-based routing and things like that. So you can point specific URI patterns to one node or one type of node, and other patterns to that type of node. So you could basically have one single entry point for multiple applications. And that's very similar to what you have with these expensive products for that specific purpose, right? In on-premise infrastructure. And it's especially useful if you, let's say that you want to scale based on a temporary need of additional capacity. For instance, like if there is some kind of voting campaign in some kind of TV show, then naturally you won't need the capacity to take care of all the voting over time for many years from now. You just need that for that specific window. And maybe you need the site to be available a couple of weeks from now, but maybe with 1/5 of the capacity that you have during the when the actual voting takes place. So this is handled dynamically by the platform. If you scale up with multiple server instances with what's called an auto-scaling group, then if that auto-scaling group is pointed to a specific load balancer, if new nodes, if new virtual machines are added to that auto-scaling group dynamically, depending on the need, then those nodes are automatically associated with the load balancer. And the same the other way around. If nodes are removed, then those are drained and removed from the load balancer again. So there are tons of manual work that is just obsolete if you move operations to the cloud. When you want stuff to be available, you want stuff to be easy to patch, right? Easy to upgrade, and easy to recover if, for some reason, stuff goes wrong. Because eventually it does, right? Then you want to build immutable and stateless services. If you have a stateless service, there's nothing to keep from that specific server instance. We just wipe that server instance and install a new one. Ideally, we'll provision a new one before we wipe the old one, right? To keep the system as available as possible. And usually it's not about like one server being replaced with another. Usually it's rolling upgrades where you maybe you have 5 different instances and you add a 6th. And then you can shut down one of the old ones and you continue doing the same until you have 5 brand new instances. But there's no longer any point in trying to patch the OS as long as you can build your application servers stateless. There's no point in patching or triaging what's wrong with a specific server instance. It's a lot easier to just wipe that one away. So this goes for distributed systems. It's especially with maintenance and patch management. So this is a new way of thinking, right? Rather than upgrading a server, we just install a new one again. The key to all this is to automate everything. Automate as much as possible. We're going to look at how you can administer this using automated tools, which is really simple. There's tons of stuff built in. But you can script as much as possible. As I mentioned, with this simple example, you just provision one additional web server on the side of the existing one, and you shut down the other once the new one is in a load balancer, if you're using a load balancer, or if you have pointed the DNS to the new one instead. So this reduces downtime a lot, and this makes the provisioning process and the upgrade process a lot more deterministic. You have the ability to if you're familiar with blue-green deployment, that's very similar to this, that you have the ability to make sure that everything works on the newest instance after we have upgraded to the latest operating system and the latest patches for system libraries. We can make sure that the server actually still works and that it works in our production environment, not only in our system testing environment. And let's take a look at the management tools. And then we're going to talk a little bit more about security after that. So the easiest way, if you're new to AWS or Azure for that matter, the easiest way is to get to know stuff is probably to just dive into the web portal. And in my example here, I have 3 running instances. That's not that much, but this is our development and lab environment currently, where you see the different EC2 instances. We have basically everything in the web portal needed. So, of course, we can, if we want to, we can go in and start this virtual machine, and eventually that will be assigned, dynamically assigned a new IP address and everything. So this is quite flexible if you're developing or if you're just testing stuff. But if you want to build stuff at scale, you need to automate, as I talked about before. And let me shut that camera down, and maybe that as well. And let's take a look at how we can do that with the different administration tools instead. So this is an example of a CloudFormation template. This is, as you can see, it's written in JSON, but this can also be written in YAML nowadays. I would definitely recommend using YAML instead because it's a lot easier to overview. So, but in this example, it's JSON. And I think it's still worth understanding the JSON format, because these CloudFormation templates pops up everywhere now, where application vendors provide a CloudFormation template as an installation recipe. If you want to provision their solution in your AWS environment, you can just use their readily built CloudFormation template and use that to instantiate the entire environment. So we won't have time to go through all of these, but just to show the basic concepts, a CloudFormation template has a couple of parameters where we can define some input parameters that might vary from one instantiation to another. For instance, what type of EC2 instance, hardware configuration, if you like. So what type of EC2 instance configuration that we'd like to use for the EC2 machines in this CloudFormation environment. And this will instantiate one virtual private cloud, VPC. Let's move down to the bottom instead, because the stuff at the top are very detailed. I've defined like what subnets that should exist, what subnets that should be in each availability zone, how these subnets are tied together, and things like that. But the most interesting here is that this is an example of a setup of Confluence. If you haven't heard about Confluence, it's a very great wiki application. But in this example, we can instantiate a database as a service. So this is all the configuration required for setting up a Postgres database. It's not that much, right? Rather than installing a machine where Postgres should be, and installing Postgres database on that, configuring Postgres on that, setting up automated backups, because that's taken care of as well, and performing the patching and upgrading on that eventually when there are new system patches coming out on Postgres. All of that is seamlessly taken care of in RDS, the database as a service concept in AWS. So I just need to worry about the master username, the master user password. This is just for as an example. Ideally, you would have a dynamically generated password in as an input parameter to this environment. And in most situations, if it's one thing if this is for lab purpose, but if it's in a production environment, this is usually changed once you come into the production environment anyway. So this is just to get stuff going and start off from there. And you can define a dedicated security group. I'm going to talk more about what security groups are later. But that's basically a stateful firewall. And the database will be part of a security group enabling TCP access on specific ports. So this is the from port and the to port. So we even have the firewall configuration for the database itself within the CloudFormation template as well. If we continue up, this is the security group configuration for the web servers. And in this, we define that SSH port 22 should be open, and we should also open up port 8090, and we want to open that up for members of the security group called load balancer security group. So you can make references to other stuff in this CloudFormation template. So the load balancer security group is defined here. So now if we are in the load balancer configuration, we want to enable HTTPS access on port 443. Nothing more, nothing less. And we want to have egress traffic allowed from the load balancer to the web servers on port 8090. And the configuration of the Elastic Load Balancer, we can refer to an existing SSL certificate within the AWS environment, so that the load balancer will be automatically configured using TLS, and we don't have to worry about generating our private keys in a specific place and transferring those private keys in a secure way into AWS. These private keys never leave the AWS environment. And the TLS configuration is grade A+ by default, so there's a lot bigger chance that you'll mess things up if you try to set up a secure TLS configuration yourself. And we continue up. There is also a concept called network ACLs, access control lists for a specific subnet. And this is stateless, so you have to define traffic that should be allowed in both ways. So if you have TCP, then you need to define that the session ports should be allowed as well, not only for the egress traffic. In terms of, so you might wonder, there are network ACLs and there are security groups. They seem to serve a similar purpose, but the difference is that security groups are stateful, while network ACLs are stateless, and that makes them a lot more difficult to maintain. So I would definitely recommend making the basic building blocks in terms of security for your entire subnet in network ACLs. But the fine-grained configuration is a lot easier to handle within your security group. But as long as you automate things, there's nothing wrong in having both, right? So this is, again, very fine-grained. You can tweak basically everything so that it's designed in a least privilege fashion, rather than if a certain web application server only should allow traffic on port 443, then we shouldn't have anything else allowed from the internet or from the application server to the outside, for that matter. We should, if it only requires traffic to be allowed to the database server, then nothing else should be allowed. So think about Marcus's and the other guys' presentations yesterday about lateral movement. Marcus and Fabio was presenting on that, right? So lateral movement is very limited if you use security groups and network ACLs correctly. And it's also, remember, breaking the complex monolithic structure. If you do that, it's a lot easier to review and overview the security configuration of your environment. We can use one of the greatest benefits of CloudFormation that I didn't mention is that once you instantiate a CloudFormation template, then that is handled within the same transaction. So you can still make scripts or use CLI to create your database and create your web server and create your load balancer and point your load balancer to the web servers, etc., etc. You can still do all of that in an automated fashion. But with CloudFormation, all of this is taken care of within the same transaction, which means that stuff that belongs together is instantiated in the correct order, depending on what's dependent on what. Which means that if the database have to be created before the web server, then CloudFormation takes care of that automatically for you. Which is quite good, right? So if you have a lab environment or a testing environment, for instance, then you just instantiate everything. When you're ready with the usage of that environment, you just wipe the entire stack. And instantiating is as simple as running AWS. Maybe I should resize that a bit. Instantiating is as simple as AWS CloudFormation, create stack. We give the stack a name, demo stack. Bam. Well, that seemed like magic, right? So that doesn't necessarily mean that you already have a database ready to use and installed and configured correctly. But this means that the CloudFormation instantiation has begun. And we can view the progress of that if we move to CloudFormation in the web. You see, create in progress. So you see that network ACL entries are being created, security groups are being created, and the internet gateways already been created. So this will say create in progress for a couple of more minutes, and then everything is up and running. Maybe we can see, depending on how fast it is at AWS today, we might be able to see that EC2 instances are already spinning up. Loading, loading, loading. Look at that. So virtual machines are already being created. Pending, initializing, stuff's happening already. So in that CloudFormation template, I never showed that, but in that CloudFormation template, the configuration is that I want to have 2 web servers instantiated. I want to have 1 load balancer pointing to those 2. So the 2 application servers belong to the same auto-scaling group. We can look at that under auto-scaling group. We should hopefully have the demo stack. You see that it gets a dynamically generated name or a suffix after what I call it in CloudFormation. And this is just so if I want to, I should be able to instantiate a complete copy of the same stack on the side. So that's the reason why it has to be dynamically generated, the names. You see that this is the desired number of instances is 2. It should never be less than 1, so there should always be 1 machine up and running. But I could easily, I'm not going to do that now, but I could easily change desired number of instances to 10. And that would just provision 8 new machines with the same configuration. That's quite neat, right? And if we go back into instances, see what's happened. These are the instances that's being created. We can click on security groups. This is the application server security group for the demo stack. And you'll see that, well, I shouldn't have done this because this is a big don't. Never open up SSH to everyone like this. But you have the ability to set like specific TCP ports or a port range that's going to be accepted, and the source is where the traffic should be allowed from. And again, if I'm no longer in need of this anymore, I can shut it down again. There was a command here, by the way, which is quite good. If you just retrieve the content of that, ipinfo.io/IP, you'll get what IP address you're connecting from. So it's a lot better to limit the traffic from that address only if you actually need the SSH protocol to be open. But if you build stuff immutable and stateless, remember, then there shouldn't be a big need of having SSH allowed. Some people build this with jump stations where you have dedicated machines where you jump through SSH over to the next machine that you actually need to control or administer. But if you do have jump stations like that, utilize the fact that this is controllable through CLI and through automation. So if you use the jump station for a specific purpose within a short period of time, start the virtual machine by that time only. And when you're done, shut it down again. There's no need for it to be up constantly. So if we go back to the CloudFormation web, we should be able to see that the delete is in progress. So now everything happens backwards. It says create failed because I interrupted the creation process of the database instance. That's usually what takes the most time. Database and CloudFront, which is the CDN configuration. Those are things that typically take like 10 to 15 minutes. But who of you can say that you're able to set up and configure a database within 10 minutes? Quite few. So it's extremely efficient, yet still a bit scary, of course, from a security perspective. So we're going to dig a little bit deeper into security and talk about that for a while. There are some security features built in. I talked about some of them already. Security groups being the stateful firewall, network ACLs being stateless, and something you could use for less fine-grained control. We have support for encryption at rest and encryption in transit through the TLS, readily built TLS configuration. But we should remember, in terms of encryption at rest, there are going to be talks about encryption later and in terms of compliance and regulatory requirements. But I'd just like to mention about this, that encryption in this context doesn't necessarily mean your information is secure. You have to ask yourself, secure from whom? Because it might be secure if somebody goes into the data center and grabs one of the hard drives. Then your information might be secure because the keys are handled in dedicated hardware security modules. But if an attacker finds a SQL injection, for instance, or a direct object reference that can enumerate all your customer details in your web system, that doesn't get solved by having encrypted databases or encrypted storage. So we need to think about what encryption means and what type of encryption we have in our environment. And ideally, you'll move the encryption keys as close as possible to the customers or the end users, rather than having the encryption keys as close as possible to the encrypted data. For instance, what point is it having an encrypted database with the encryption keys in the database? There's not much benefit in that. But yet, still, there are services that are built like that. Encryption, yes, no. And if you click yes, that means it's going to be encrypted, but stuff is handled in the clear anyway, especially in the application service. Data is always in plain text. It's encrypted once it reaches the database, and decrypted once it's being retrieved from the database. Security Manager, I just mentioned briefly that we refer the load balancer to a specific TLS certificate. That was the long ID, remember? And that's very good in terms of not having to care about where we generate the private keys, how do we transfer the private keys into the cloud, and how do we make sure that the private keys are wiped or backed up on our machines. So in this case, if you use Certificate Manager, all of that is handled transparently. So you don't have to worry about generating keys yourselves. And also, you can have Amazon take care of the renewal process of certificates. Because that happens eventually, right? After like 2-3 years, all of a sudden everyone realizes that everything stopped working. And the reason is simply because the certificate is expired. This is a great way of handling that. Again, with A+ TLS in terms of SSL labs testing and things like that. And there were tons of monitoring and detection features. We don't have time to talk about all these. The identity and access management functionality is very fine granular. When you register for Amazon Web Services, you get a root account. Don't use that. Well, you need to use it for one thing, and that's for creating other accounts, basically. And a few other stuff. But don't use that regularly for administering your environment, because that's really the keys to the kingdom. And again, the identity and access management portal is extremely flexible. You can create accounts that's connected to specific privileges. For instance, I want this account to have read-only access to only RDS, the database as a service offering. And that means that that account won't have any access to creating new virtual machines or reaching the virtual machines within your EC2 environment. You can limit the access. Let's say that you want this access to only be valid for like 24 hours. That's also possible. Or you want that access to only be valid for a specific storage bucket, for instance. Always follow the principle of least privileges. And the key to this is automation. If you automate everything, then you have the ability to set very restricted policies for a specific account. In our traditional environments, we've done the opposite, right? We've had a few different groups and users belonging to these administrators groups, which basically means access to everything. It's time to break that concept and look more at automation. Multi-factor authentication is extremely simple to use. I use the Google Authenticator application as a virtual multi-factor application. if you want to, you can have Gemalto cards and like dedicated hardware for multi-factor authentication. But I mean, using Google Authenticator and having a mobile app for generating the one-time passwords, that's a lot better than not having multi-factor authentication. I already talked about security groups. I see that I'm shortly running out of time. I'm just explaining this briefly to give a quick recap on that. It's a stateful firewall. It's something that you don't control per virtual machine. You set the TCP/IP rules allowed for a specific group, and then you put members into that group. And you can put members dynamically into that group over time. For instance, if you auto-scale to more instances. And the same goes with this. Follow the principle of least privileges. If we only use TCP traffic, then why should we allow UDP traffic? Then it should be TCP only, accepted by those hosts. And we build our security in multiple layers. So we have the database being least privileged designed. We have the web servers in the same concept. We have the load balancer in the same fashion. My clicker gave up. Talking about encryption at rest, just to repeat, there are hardware security modules, dedicated hardware for the encryption keys. This is mainly for compliance purpose. If you have to use this, then it can definitely lease the burden in terms of compliance and assessments. You can just point towards that the cloud vendor is already compliant to some extent. This is well integrated with some of the existing features like S3. I didn't talk about that, but maybe you heard about S3 being like storage as a service. There are more storage concepts like Glacier, where you have a more low cost for persistent storage of logs, for instance. Glacier is perfect because S3 can get quite expensive if you save terabytes of data. We don't have time to dig into CloudWatch and CloudTrail, but just to mention that it's available. CloudWatch is monitoring built in, where you can set up alarms depending on that all of a sudden I'm short on the number of instances. I want alarms saying that. So if somebody accidentally shut down one of my EC2 instances, I want an alarm to be sent over email, for instance. You can also collect logs in CloudWatch. CloudTrail is more or less AWS-wide log saying all the events that occurred within your AWS account. For instance, this database was created or this database was deleted by this specific user at this time. That's great for tracking purposes. And you can stream those logs to S3 and move them eventually to Glacier and save them for years from now. That's very important. Remember what we talked about yesterday, that you need, once you eventually realize that you have been under breach a couple of years back, then you need to dig through your logs and find that specific time. So I'm just going to leave the recommendations here and think about the level of abstraction and control needed, because that's going to affect a lot in terms of how flexible you are, how agile your team is. The more abstract you are in your implementation. So if you're going serverless, or if you're going platform as a service at least, then it will be a lot easier to administer your environment. And eventually it's going to be a lot easier to move to another cloud vendor, if you like, later. follow the principle of least privileges, because this, if you have automation, then there is no point in opening up to the world for everything. And don't rely on just the fact that it says encrypted or encryption. You have to understand what it means in terms of encrypted at rest and see what the actual risk is if information gets into the wrong hands. And don't forget to monitor your systems. There are going to be other talks about security monitoring and implementing secure monitoring in your organization. So, but just so that you've seen that there are some functionality built in CloudWatch, for instance. I think I'm 5 minutes over, so I don't have time for questions. Sorry about that. If you have anything you'd like to ask me, just grab me in the break.
Yeah.
Thank you.
Thank you, Emil. And